So guys, a warm welcome to you. Once again, I am here to come up with a new part, that is magnetic materials. Here we will categorize certain materials on the basis of when these materials on the basis of behavior, basically on the basis of behavior, when these materials are being placed in the magnetic field. For the detailed discussions, let's proceed. Now guys, magnetic materials. So now what we're going to do, we'll compare diamagnetic, paramagnetic and ferromagnetic materials. These are the different magnetic materials: diamagnetic, paramagnetic and ferromagnetic. So these material we're going to study, we'll compare these three. So what we're going to see that if we talk about the a diamagnetic substance are those substances which are feebly repelled by a magnet, and paramagnetic substances are those substances which are feebly attracted by the magnet, means means feebly attracted. Okay, if we check out the examples for the diamagnetic, is antimony, bismuth, copper, gold. So these are the different materials. And if we talk about the paramagnetic, these are aluminium, chromium, alkalis and alkaline earth materials and etc. Now if we look at the ferromagnetic materials are the substances which are strongly attracted, not feebly. So we have seen that in paramagnetic it is strongly attracted, in paramagnetic it was feebly attracted, in this thing it is strongly attracted. So iron, cobalt, nickel, gadolinium, so these are the different ferromagnetic materials. Now let's proceed. Now if we proceed, that is, now when the diamagnetic material is placed in the magnetic field, the line of force tend to avoid the substance. Now if we check out for the paramagnetic materials, the line of force preferred to pass through the substance rather than air. And so this is somewhat like this. So if it is being if a diamagnetic material is placed something like this, so it becomes something like this. And if a paramagnetic material is placed in the magnetic field, so it tries to go through the material. Now if we talk about the ferromagnetic material, so in ferromagnetic materials all the lines try to pass through this, so the line of force tend to crowd into the specimen. Now, when placed in a non-magnetic field, it moves from stronger to weaker field because of its repulsion. And when placed in the non-magnetic field, it moves from, this is the paramagnetic, it moves from weaker to stronger field because there is a feeble attraction. Now, if we talk about the ferromagnetic material, when placed in a non-magnetic field, it moves from weaker to stronger field. This is because it has a strong attraction. Now if we check out the next difference, when a diamagnetic material is feebly suspended in the uniform magnetic field, it aligns itself in the direction perpendicular to the field. And if we check out for the paramagnetic material, so in paramagnetic material the rod is freely suspended, then in the magnetic field then it aligns itself parallel to the field. Now let's look at this diagrammatically. What exactly is the thing? That let's say this is the diamagnetic rod, and if you apply the magnetic field, the orientation becomes something like this, because it has to repel, because it is because of its repulsion. Now similarly this goes with the paramagnetic material, and if you place the paramagnetic material in the magnetic field, this becomes something like this. So we can see that this aligns itself parallelly slowly. So let's move towards the ferromagnetic material. When a ferromagnetic material is freely suspended in the uniform magnetic field, it aligns itself in the direction parallel to the field because of the strong attraction very quickly. Something like this. If this is the, let's say this is the ferromagnetic material. So if you apply the magnetic field, this aligns itself parallel in the direction of magnetic field very quickly. Now let's look at the next example, that if the diamagnetic liquid, now we are talking about the diamagnetic liquid. The diamagnetic liquid taken in a watch glass, is placed in a uniform magnetic field, it collects away from the center when magnetic poles are closer. That means something like this: when these are closer, because of repulsion, these are coming towards it, so therefore it will go away from the strong, means strong poles. That is, so it will be the configuration becomes something like this, and collects at the center when the magnetic poles are farther, something like this. So because it has to go away from it, so therefore it aligns at the center because the magnetic poles are far from this, and it has to repel these things. Now if we talk about the paramagnetic liquid, so taken in the watch class, it is, so the effect obviously goes, definitely it has to be the opposite to that of the diamagnetic materials. Uniform magnetic field, it collects at the center when the magnetic poles are closer, and collects away from the center when the magnetic poles are farther because of the feeble attraction. So these are something like this. When closer, so it aligns, I mean it collects at the center, and when these are farther, there is an attraction between the two, so therefore it will go to away from the center. Similarly, that the whatever is the paramagnetic, whatever is the properties of the paramagnetic liquid, the same as goes with the ferromagnetic, but these are very quickly. So if we talk about the ferromagnetic liquid taken in the watch class, is placed in the uniform magnetic field, it collects at the center when the magnetic poles are closer, and collects away from the center when the magnetic poles are farther. So this is exactly the same thing. So but in the ferromagnetic material, the things are very quickly, and in paramagnetic, the things happens to be very slowly, because of feeble attraction in paramagnetic and strong attraction in the ferromagnetic. Now let's proceed further. When a diamagnetic substance is placed in a magnetic field, it is weakly magnetized in the direction opposite to the inducing field, because of the repulsion we have studied, and when an atom does not want to align. So when a paramagnetic substance is placed in a magnetic field, it is weakly magnetized in the direction of inducing field. If we talk about this thing, induced dipole moment is small and has a negative value, because we have studied in the above difference, it is given that weakly magnetized in the direction opposite to the inducing field, so therefore it has the negative value. And induced dipole moment is small but has a positive value. Now the intensity of magnetization also has a small value, and that is also negative. And intensity of magnetization for the paramagnetic has a small but positive value. And this, let's check it out for the ferromagnetic substances. Ferromagnetic substances is placed in a magnetic field, it is strongly magnetized in the direction of inducing field. So this effects goes absolutely in the similar manner as goes with the paramagnetic material, but the things are very large. Like if we talk about the induced magnetic moment is very large, it has a positive value. In the paramagnetic, it was small, but obviously it was a positive value. So intensity of magnetization also is very large and a positive value. Now let's look at the example. So if you look at the example, the substance which shows the permanent magnetism. So we have seen that that if we talk about the different materials, there is only single material because of or in or which or have or if there is only single material in which there is a strong attraction towards the magnetic field, there is only a ferromagnetic material. So according to that, option C should be correct, that is the ferromagnetic material. So this is a substance which is used for permanent magnetism. Okay, so let's look at the next example. The relative permeability of a substance A is slightly greater than 1. That means they are talking about the permeability. So if we talk about the susceptibility, we know that they are asking about permeability, and permeability can be written as 1 plus chi m, that is the susceptibility. and we have seen that the susceptibility for the diamagnetic material is negative, small and negative, and this is for the diamagnetic material. For the paramagnetic material, the susceptibility is positive but has a small value. Ferromagnetic material, this is positive but large, but more than for the paramagnetic. So if we talk about this thing, so it is saying the permeability of a substance is slightly greater than 1. That means the relative permeability of another substance B is less than 1. So if it is less than 1, then we have to check it out that if for this is mu r is coming out to be less than 1, that means positive value but less than 1, and this mu r is slightly greater than 1 or but has a positive value. So substance A is diamagnetic, that cannot be possible because it has a value slightly greater than 1, and B is paramagnetic. No, that is not even correct. So substance A is paramagnetic and B is diamagnetic. Yes, this is coming out to be correct. Let's check it out the other example also, and the both are paramagnetic. Substance A is paramagnetic and substance B is ferromagnetic. So therefore option B should be correct, because it is already given, because we know this thing that it is negative, it is negative, so 1 plus negative will comes out to be less than 1. So for that, B is diamagnetic, and the relative permeability of the another substance A is slightly greater than 1, so therefore it is paramagnetic.
Hopefully guys, you have enjoyed listening this part. Already we had a lot of discussion about this part, so I'll not discuss about that part, but just to inform you that I'll come up with a new part, that is hysteresis and magnetism. For that, stay tuned.